Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL online certification course in structural systems in architecture. This is the 8th or the last week spatial structures, and this is the second lecture on the spatial structure, and today we are going to discuss about the building foundation. In continuation, this is the lecture number 37. So, today we will going to cover those are the some of the concept. Very quickly we have to go through this particular lecture and particular subject as a building foundation. So, in that we will introduce the thing, introduce the topic, and then we will discuss the soil bearing capacity, then the types of foundation, shallow foundation, deep foundation, and for reasons for the foundation failure. And the learning objective, we will going to discuss the fundamentals of the soil bearing capacity. We will outline the shallow and deep foundation, and we will discuss the foundation failure. Actually, it is very vast topic, this particular foundations and soil mechanics, and it required a rigorous kind of a expertise to deal. It is not only the structural engineers, geotechnical engineers are actually deal with this. We will have to cover it half an hour time and quickly, because we have to need to know some of the glimpse of it. It is a specialized field in the civil engineering and the building which deals with the building foundation. And if you see the building foundation, it has two separate part or area of the studies. One is called the soil mechanics and another one is called the foundation engineering. The soil mechanics is that deals with the properties and the parameters of the soil. So, if you take a soil, it has actually it is a three kind of a three layered system, you may say sometimes. That is, it has some solid, it has some the air, and it also has some water in it. Three phase system we usually called it. So, based on the proportional amount of the solid and the air voids and also the water, its property changes. So, you require to investigate the soil to find out how much is the capacity of load carrying capacities also, and how much the soil can be further go for some kind of a settlement if there is some load on it, or sometimes it is consolidated for a longer period of time, how much. So, those are the typical the outcomes which people want to know before they go for any kind of a foundation system, and that covers in the soil mechanics. And then that comes the foundation engineering. The foundation engineering is deal with the different type of foundation systems and for the building and the structure, their applicability and their constructions and the design mechanism. So, in the finally we boil down to the soil bearing capacity, whatever you thought of in a particular soil mechanics. Mostly, I mean, there are a lot of other things also, but mostly the primary target is to finally find out how much is the bearing capacity. And what is bearing capacity? The bearing capacity is a capacity of a soil, particular soil, to support any imposed load, any kind of a load. So, and this particular how much it maximum or it can take, that has to be finally found out from those properties and the parameters. And if you put more load, so I have some illustration. Suppose it is a soil and there is a foundation, and there are some column or some kind of a wall, from where you can give some kind of a load. So, if there is imposed load, so there will be some kind of a contact pressure which will be opposite in direction. So, it is follow the Newton's third law, the equal and equal, any action has equal and opposite reaction. So, the contact pressure, now if you increase the load, if you suppose that it is very high amount of load, or you are not increasing the area of the foundation. So, the contact pressure will going to increase, right. And finally, it will going to give you some kind of a failure, shear failure, cracks will appear in the below the soil, and your kind of the foundation may settle down or maybe tilt, or those kind of a problem will be there. Okay, so, we have to do not load the soil till it's I mean, we do not want to have the soil is fail due to the shear or so. So, you have to finally find out the how much is the carrying capacity, either in ton per meter square or kilonewton per meter square. These two are the popular unit for the soil bearing capacity. So, the geotechnical engineers they used to do that with some soil investigations purpose. There are a lot of way, there are some laboratory tests, there are some in situ tests are there. So, they can do those and finally tell you that yes, this is this much ton per meter square is the soil bearing capacity. So, what are the factor that that affect that the bearing capacity? If you see, there is type of soil and its properties is one of the factor. Now, there are basically there are two type of soil. I mean, if you see, one called the clay type of soil and the cohesive kind of a soil, which is actually having some kind of addition. So, the one particle of the clay and another particle of the clay, if you see, they are attached with each other like a gum or the kind of glue kind of a thing. So, it is adhesion. Okay. And another type of soil is sand, which is non cohesive kind of a soil, which does not have that kind of a attachment or the adhesivity, but they have some kind of a friction with each other. So, they are, if you want to move one particle of the sand over the other particle of the sand, you have to actually overcome those kind of a friction. So, it is called the I mean, there are some soil of course has both type of variety, they are called the C5 kind of a soil, that C is the cohesion factor and the phi is the angle of friction. So, these two are the property that the some scientific property has to be found out from the testing manner, and from that you can predict the what will be the bearing capacity of the soil. So, that is one of the definitely important parameter of soil properties that you require to find out finally the bearing capacity. Then the depth of water table in your site where it is going to be constructed, the building has to be constructed, you need to know the what will be the depth of the water table. So, how much is the water that can come till how much. So, that is very important, because sometimes it is saturated, sometimes it is oversaturated, sometimes it is not saturated, fully dry condition. So, because of that variation of the moisture on the pores of the soil will going to change the character of its bearing capacity. You require this two understanding also before you jump into the bearing capacity is how much is the depth of your foundation. Definitely, because as and when your depth of the foundation is increasing, you have to actually see that particular depth how much is the capacity, it is not the any other point. And also you require to know the type of the foundation, that how much is the it is a the deep foundation, or maybe it is a shallow foundation, or which type of foundation, that is also has to be known to you. So, this is one the table that gives you some idea about the what should be the bearing capacity of the soil. So, non cohesive soil, that is sand or gravels, which is in the first part of this particular table, you see this has a very good kind of a the bearing capacity, but cohesive soil which is clay is gradually down. I mean, there are some soft clay which they write that is not applicable, it's you have to actually improve the soil or remove the soil, or you may go have to different type of foundation which is pile foundations or so for those kind of a soil. So, now the type of foundation. So, let us now go to the we probably understand what is the bearing capacities and all. Now, let us see how the foundation can be designed. So, in the foundation there are basically there are two type of foundation, or you can initially categorize two type of foundation. One is called shallow foundation and another is called the deep foundation. So, these two foundation are classified based on the the depth of the foundation and the width of the foundation. So, if I just draw, suppose this is the foundation. So, if I draw a foundation, so this foundation is having some kind of, this is the ground. So, this is the width of the foundation and this is the depth from the ground. This D and B will play a role. So, if the D is less with the width of the foundation, then it is a shallow, and if it is D is very high with respect to B, so then it is a deep foundation. We called it is a deep foundation. So, the shallow foundations are the wall footing, shallow foundations are the isolated column footing or maybe the combined footing. There are various types of combined footings also. There are rectangular footing, there are strap footing, grid flow, raft foundations are there. So, those are we will discuss now, and the deep foundations are of 3 or 4 types, but this one is very important for our use, the pile foundation. Pile foundations are used for mostly for the buildings, of course for the bridges also they can use, but well foundation, PA foundations, they are very much used not for buildings, but for other structure like railway bridge or any bridge in the water, in the river and all. Now, in the shallow foundation, let us start with the isolated footing. So, suppose there is a column which can take a load, and this load has to be taken to the foundation. So, we are going to spread up the legs of the foundation. It is something like your leg. So, the load of whole body, human body is actually spread by the feet. So, you need to increase the contact area such a way that it distribute the load to in the soil within the zone of the soil bearing capacities also. So, the single foundation is dedicated to a single column. If that is so, that is it is called as isolated foundation. The square or rectangular can be shaped, sometimes it is circular also. The area of the foundation should be such that the load should be safely distributed over the soil. That is true. Suppose I take a example of that the column is taking 270 kilonewton load and the soil bearing capacity is 90 kilonewton per meter. So, I can easily say that the area of the foundation should be the column load by the soil bearing capacity. So, here it is 3 meter square. So, this has to be the 3 meter square. So, if it is a square, it should be root 3 by root 3, something like that, right. So, if yes, it is root 3 by root 3. So, 1.73 meter by 1.73 meter both the side, and suppose you have a column layout in your building such a way that each column is taking 270 kilonewton and the distance between the column to column is 4.5 meters. So, you put your the foundation of this 1.73 meter by 1.73 meter, and you will find out there is a gap is still exists between these two, is almost about 2.7. So, this is your 2.77 meter or so, right. So, like that, if our isolated foundation will going to work or can be placed in a particular structure. So, the particular for a particular structure. So, those are the isolated foundation. It is called also the pad foundation sometimes. Suppose the column load, I have increased the column load. So, instead of the, I think there are 270, now it is 800 kilonewton. So, the foundation area now increases almost 9 meter square. So, I kept is 3 meter by 3 meter, right. So, that gives me a square footing of square isolated foundation of 9. Now, if I have the same module with me, so that is 4.5 by 4.5 is the grid size. So, now if I place this 3, so the gap is now 1.5 meter. Sometimes it is furthermore close, because if the loading is much high, so this 3 is also going to high, so this is going to less. So, the gap between the foundation is sometimes less. So, if you furthermore increase it, so sometimes it may happen that the gaps are too narrow, gaps are there, or sometimes it may be the foundation are overlapped. This is overlapping case, so it may overlap. So, what do you do then? If it is overlap both the foundations, then we can have to we have to think for the common foundation or the combined foundation. So, we can go for the combined foundation or rectangular footing. So, where both the foundation are taken together and design accordingly. So, in that case we can have a small design example of this rectangular footing. So, those are the rectangular footing you see. So, let us consider a case where the two loads, if the two loads are similar, it is very easy, because you know the exactly it is then in the center. But if the two loads to the C 1 and C 2 are the two columns like this is suppose C 1 and this is suppose C 2, and this is having the P 1 and this is having some P 2. So, the load is differentiate loading. So, like that I have kept C 1 as 240 and C 2 as 360 kilonewton. The distance between the columns are of 2.5 meter, that means this distance are of 2500. Okay. So, and the safe bearing capacity, soil bearing capacity is 75 kilonewton per meter square suppose. Then how can I see if these two loads are acting in a particular foundation. So, this black color line is suppose the foundation. The reaction, opposite reaction, the equal and opposite reaction is 600. Why 600? This is 360 by plus 240 is 600, has to act such a point will not be exactly at the center of this 2.5 meter, because it is from the parallel forces point of view. If you remember very first week lecture, you can find out the position of this 600 by virtue of taking moment at this particular point. I have taken the moment at this particular point. So, it is 600 into x, which keeps the moment like this, must be equal to 360 into 2.5, because the distance from here to here it is 2.5. So, I found out that the x is 1.5 meter. So, 1.5 meter from C 1, and that means and 1 meter from C 2, the reaction will go, that is the CG of the load, that is the CG of the combined load, right. Now, let us take another thing, how much area of the foundation is required. So, that is very easy, because I know the total load is 600 and that has to be divided by the soil bearing capacity 7.5, and that gives me 8 meter square of the area, and I am keeping the L is to be equal to 2:1, the L is twice as large as the width of the foundation. So, I can find out finally the B is 2 meter and L is 4 meter. Okay. So, from that I can now locate such a way that the CG of this is very important, that for locating this continuous, the common foundation, this rectangular foundation, the CG of the loading which I have found out must be coincide with the CG of the footing. So, CG of the footing, so this is 2 meter and 2 meter. Why it is CG of the footing? Because it is L is equal to your, let me erase it and then tell you. So, this is your L, which is your how much, 4 meter. So, this is the CG of the footing, and this is your, this yellow point is your CG of the load, because why? Because this is 1.5 meter, this is your x, what I found out, and this is your 1 meter. So, those 2 points has to be merged together, right, and if these two are merging together, then and rest of the dimensions you can adjust accordingly. So, the C 1 has to be at a distance 0.5 meter from the edge, and C 2 has to be at the 0.1 meter from the edge. So, there will be some kind of a differential kind of a placing to maintain this particular the criteria, the CG of the loading should be coincide with the CG of the footing also. Next is this, suppose this is the case where I have the foundation isolated footing and there is no problem at all, there are sufficient gaps also, but this is your property line, this is your property, this is your property, this side is your property, this side is somebody else. So, then you cannot actually go with this cannot allowed, because this somebody will not allow to excavate and put your foundation in this area, right. So, you have to left with a kind of a foundation over here, and this is a strap beam has to be connected with the other other. Even though there is a sufficient amount of gap is exist, but still you have to use a strap kind of a thing, which is also called as a cantilever footing. Cantilever footing. Okay, so this will be like a cantilever, and this will be like a connecting to that. Otherwise, there will be kind of a differential kind of a movement, and this particular because this cantilever, why? Because this part is, if you see the section, this is cantilever, and this is okay. This part is okay. So you need a kind of a strap. This is the strap beam. Okay, and sometimes in the I have the sketch in the other way also. I mean, this is kind of a strap, and these are the kind of that strap I have just now shown. And there are sometimes the two typical foundations, normal foundations can also come under the strap beam or those kinds of plinth beam. And this is the one of the photograph of the strap beam construction. This is at the edge. These two foundations are at the edge. So then the combined foundation go for the grid. So you have a connectivity. Sometimes it is required because there are some kind of a differential settlements also. So you can have a kind of a grid, combined grid flooring, and then finally we can go some kind of a raft flooring or the mat foundation. So whole building is under a kind of a mat or kind of this kind of a thing. So there are different type of the raft floor can be or kind of is also thought of. Now next let us go to the deep foundation. The pile is one of the type is called as a deep foundation. This is a thin kind of a cross sections and long in length, and that is actually act along penetrate in the soil and to transmit the load to a particular soil strata to required depth. And the pile foundations are also capable of providing stability against any kind of a uplift or so. So the pile has been proposed. Where we can propose the pile? So the first is that when the top soil is having very low bearing capacity, very muddy kind of a thing, the foundation is subjected to a very high amount of concentrated load. So that much concentrated load is if you discharge, you require a raft or those kind of foundation, which fourth point I have mentioned, when the raft foundation is not economical. So you may think of going with the pile foundation, and the building over the marshy land where the waterlogged area, marshy land, in that area you cannot actually rely on the shallow foundation, because those just beneath of that particular shallow foundation depth is low, the bearing capacity is very poor. There are different types of the pile foundation, and the pile foundation types of the pile foundation is based on different requirements. So first one is based on the load transmission point of view, and from that point of view it is classified as the end bearing pile and the friction pile. We will discuss that what are those. And next is the based on the materials, we can have the concrete pile, we can have the sand pile. Sand can sometimes use, of course not for taking load, but for compaction and all, drainage, increasing the drainage and all. Then there are steel pile, there are some kind of the timber pile, or sometimes it is composite kind of pile. Based on the function, it is load bearing pile, which I have just now told, that is friction pile and the end bearing pile. There are sheet pile, the sheets can be steel sheets or the timber sheets also can be used as a pile to protect a particular foundation or some kind of a underneath structure because of some kind of a vibrations also. We have a compaction pile which used to improve the soil bearing capacity of a very loose area, loose soil. We used to put the compaction piles and then we start construction, other foundation. There are some anchor pile also, which is actually protect your structure from the uplift. And also from the based on the construction methods, also you can there are two types. One is called precast pile, and which is, as name suggests, you cast in the factory and that is transported to the site and you place it on the or put it in the site. And the second one is the cast in situ, it is cast in situ itself, site itself. Let us discuss about the some parts of the pile foundation. The column is actually going to transmit the load to the pile or the foundation, and pile foundation will transmit the load to the soil, right. So, column will transfer the load to the pile cap. So, there is a huge thick, see in the photograph you see this is a huge column, maybe for any kind of it is making some kind of a bridge or so, and it has a huge amount of the base, which is a pile cap, and pile cap is actually going to house number of piles. It starts from 3, 4, 5 like that. Okay. So, these pile caps are there, which is a cylindrical long portions which penetrate the ground to a certain amount of depth and transmit the load. So, and it is called as a group of pile. It cannot be one single pile and one single column. It may be minimum 3 piles or maximum maybe any number. It can be accommodated in a particular area. And finally, it goes with a pile shoe, that is going to be the end portion of the pile, which is a kind of a sharp edge. So, that the two type of classification from the load carrying capacity of the pile is that the end bearing pile is that it's actually finally transmit the load at the end. So, it is something like that if you take a glass of water and you want to place something like a pile or some stick or some pencil. Okay, so, the water cannot take the load, right. So, you have to actually rely on the tip of the glass or so that is the hard status. So, you have to actually transfer the load through the pencil to the tip of the glass. So, that is a kind of the end bearing pile, right. So, that is the end bearing pile. So, and this is called another one is called the friction pile. So, it is friction is generated between the pile surface and the soil. So, suppose that glass which I have just now told is the water is replaced by the sand. Now, if you just want to put a pencil, maybe you can just put half of the glass, you may not reach till the end the tip of the glass, and that particular pencil can stand, it can transmit the load. So, how it is possible? Because as and when there is a load come, there is a friction generated between the sand particles and the surface of your pencil or whatever. So, and that transfer the load. So, that way also you may not reach to the final destination or the final hard rock strata. So, if your soil is good enough, sandy kind of a soil, so it can transfer the load by virtue of the skin friction, that is called the skin friction. So, here we will see how I derive a small mathematical problem. So, see, I have a column load of 1200 kilonewton, and I have a 4 pile group, and I know these are the type of a soil strata. The top 5 meter of the soil is having skin friction 20 kilonewton per meter square, and below that I have another good soil which is having 25, little better. So, I have to find out that how much will be the penetration depth in the second layer. So, design load of the one pile is 300 kilonewton, because you know that 4 piles. So, it is one pile has to take 300, and then the total thing can take care of the 1200 load. So, let the diameter of the pile be 300 mm, I have assumed that. So, the for 5 meter, top 5 meter, this is the supporting load, because this is the area of the surface area of the pile in the depth of 5 meter, because it is, you see, this is, I have used this formula. So, this is the surface area, if this is your d and this is your L. So, it is pi d is the perimeter into L is the volume of this the curved surface of the cylinder. So, this pi d L, pi d in meter and L 5, and this is 20 is your nothing but this one, the skin friction. So, I got 94.5 kilonewton can be transmitted by the skin friction in the first depth of 5 meter depth of the soil of your giving your this 300 mm pile. Now, let the next length I have to find out h. So, I again found out the perimeter, the length, and multiply that by 25, because the second layer is 25 kilonewton per meter square, and the remaining load is I have to actually support 300, and 94 is supported by the first half or the top layer. So, this is the remaining load. So, I have equation and I solve and I found out that the height of the penetration in the second layer is 8.7 meter. So, you need almost 13-14 meter, 13.7 14 meter of the length of the pile to support 4 number of pile to support the column, right. So, like that. So, the finally, it was found I have some reasons this is also very important, the reasons for foundation failure. The reasons for foundation failures are unequal settlement, the presence of expansive soil. Soil is very expansive, suppose in the dry time or the summer time it is very shrink, very the volume is very less, and then when it is this monsoon, because of the presence of water it expands. So, it has no capacity at all from the bearing capacity point of view. So, that is one of the reason for failure. Rising of the water table, that is also moist the soil, and that we required some kind of treatment to that one, or you need to know that what will be the actual bearing capacity in time of with the water table if it is high. Foundation damage by the tree roots, foundation damage by the rat holes, those are the issues, and soil liquefaction due to the earthquake is another way, another reason that the foundation failure. And there are settlement is one of the major issue, and in that we have 3 type of settlement that let me discuss quickly before we come to the end. The first one is the uniform settlement, where the whole building settle like uniformly. So, both the part or all the part uniformly settle down, that does not create any kind of a problem, no crack will going to develop, but your plinth level is decreasing or something like your height, or you can have some other problem like water may come into your building after certain settlement or so. The second was is called the tripling settlement, where the building will keep intact, but one side it will be under uplift and another side will be under a push in. So, there also sometimes initial stages there will be no such crack is developed, but finally sometimes if it is not that smooth, there may be some kind of a crack is developed. But the third one is very dangerous, which is called the differential settlement. That means the one part is only trying to settle, because there are some problem in this soil, suppose there is some expansive soil or some kind of a low bearing capacity soil, and you have not tested the soil properly, and because of the moisture raising and all, there may be a problem and differential settlement. So, in that case there will be some kind of a crack will going to develop. So, that is all for today's lecture on building foundation. So, what we understand from here is that the building bearing capacity of soil plays a key role in the foundation system design, and shallow and deep foundations are 2 type of foundation generally used for the building. This is the 37th lecture. Next lecture will go to the high rise building in the structural systems. Thank you very much.